Today's lesson video is going to cover absolute value and multiplying decimals review. Please add page 52 and page 53 notes to the notebook. So in class, we talk about why we really have absolute value. So for example, how far is parking lot 5 from the ground level? So if we look at direction, it's at -5. But if we want to know how far away it is, that's distance, and distance is always positive. So the distance is 5 levels. So the absolute value of -5 is 5, because absolute value using these symbols represents how far away is -5 from 0. -5 is 5 units away from 0. Just to use this example again, how far is the first floor from 0, or the ground level? Well, once again, we're doing distance, so it'll be positive. It's also positive direction. So it is 1. The absolute value of 1, therefore, is still a positive 1, because absolute value refers to distance. So the value that comes out of the absolute value symbol will be a positive. So for example, if you owe $377.50, how far away is this from a zero balance? That's the same thing as asking for the absolute value of -$377.50. And therefore, it's a positive $377.50. If you saved $150, how much can you spend before you have $0 left? Well, the absolute value of $150 is $150. So don't change a positive into a negative, because absolute value is always going to result in a positive when it comes out of the absolute value symbols. Okay, so now we're going to be looking at page 52 of your notebook. The distance of a number from 0 is the definition for absolute value, and the symbol is 2 straight up and down lines that kind of look like goalposts. An example we have is absolute value of +7 is 7, and the absolute value of -3 equals 3. So 2 separate examples there. Common mistake is changing whatever the absolute value is into the opposite of. Absolute value does not mean opposite of, it means the distance. So therefore, here was the correct example. This is the common mistake. Non-examples would be parentheses around the 3 and brackets around the -9. Absolute value is the magnitude of a value, and it's always positive. So those are the characteristics for absolute value. Now we're right below the vocab for absolute value. The distance of 9.2 from 0, we would write that with the absolute value symbols 9.2 equals a positive 9.2. The distance of -25 from 0, we use the absolute value symbol. The absolute value of -25 is positive 25. And the last one, the absolute value of -8.6 equals positive 8.6. Now we have 2 examples here that are pre-done when we're simplifying absolute value expressions. This first one here, we do the absolute value of -19, which becomes a positive 19. And then we do the absolute value of -3, which becomes a positive 3, and we bring the negative down. So the -3 here has become a positive, and this minus sign is still here, because we're doing the grouping symbol when we think about GEMDAS. So 19 minus 3 is 16. Then over here, we simplify inside the grouping symbol first. We're doing the G. So -10 plus 16 is a positive 6. And then the absolute value of 6 is just 6. And then I would recommend, if you're using pencil, to try 1 through 4 first, and then watch the video to see how you did. So the absolute value of -18 is positive 18. The absolute value of positive 4 is 4. 18 plus 4 is 22. On this one, you simplify inside the absolute value symbols first. So you get 4 minus 7, which is -3. The absolute value of -3 is positive 3. Over here, the absolute value of 20.5. Oh, and on here, you're not doing a plus plus like we would with integer math, because we have to do the grouping symbol first. So 20.5 is a positive 20.5 still. The -6.5 becomes a positive 6.5, but the minus stays a minus sign and comes down. And then you subtract these two and get 14. Here, negative 11 in the absolute value becomes a positive 11. Positive 72 stays a positive 72. The minus stays a minus, so 11 minus 72, and our final simplified answer is negative 61. Okay, now we're going to look at our review of decimals. So in class, we talk a little bit about what people think these answers are. And then we do watch a video from Math Antics. So if you did want to watch that video, you could go to YouTube and search Math Antics multiplying decimals, and you will see the video. So multiplying decimals, you got to move it. So I showed this or listen to this little clip here because we got to move the decimals.
I like to move it. I like to move it. I like to move it. You like to move it.
So you multiply 67 times 4 as if there aren't any decimals. So 7 times 4 is 28, carry the 2. 4 times 6 is 24. Plus the 2 is 26. That's how we get this number. And then however many numbers are behind the decimal in the problem, you have to make sure that many numbers are behind the decimal in your final answer. So on this one, we have 2 numbers behind the decimal. On this one, we have 1 number behind the decimal. And therefore 2 plus 1 means we have to have 3 numbers behind the decimal in our final answer. So you can count them by doing these lines, add a 0 to the front, and make sure you have your decimal. So on the next, we did this in class. So checking for understanding. So you can do this as you watch the video. How many numbers in the final answer should be behind the decimal? So this one would be 3 because there's 3 here. So there's 3 numbers behind the answer once you're done multiplying. How many numbers should be behind the decimal in this final answer? 1 here, so 2 behind the decimal. How many here? So there's 3 here and 1 here, so that would be 4. So after you multiply the 2 numbers, make sure there are 4 numbers behind the decimal in your final answer. And on this one, well, there's only 1 number behind the decimal here, so you multiply and then you make sure 1 number is behind the decimal in your final answer. This is like one of the percent problems we solved this year, which is 300 times 20%. So 20% of 300 is 60. So on the little note sheet, I want you to try to do 42% of 20.5. So a reminder, our setup for percentages is like this. And then 42 hundredths is 42 hundredths. So 42% would be written like this. And so the math we need to do is 20.5 times 42% as a decimal, 0.42. So you're going to multiply this as if it was 205 times 42. So I'd recommend pausing the video and actually trying that and then watch to see how you did. So 5 times 2 is 10, carry the 1, 2 times 0 is 0 plus 1, 2 times 2 is 4. We hold 0 here for place value. 4 times 5 is 20, carry the 2, 4 times 0 is 0 plus 2, 4 times 2 is 8. Add these together, and then you have to think about how many numbers needed behind the decimal. We have 1 here, 2 here, so we need a total of 3 numbers behind the decimal. There it is. And so 42% of 20.5 is 8.61. Okay, the next one. If the tax is 8%, what is the cost of a $56 item with tax? So here's the setup, 8% of 56. So 8% as a decimal would be 8 hundredths, which would be written like this. And so we're going to be doing 56 times 0.08. 56 times 0.08. So once again, I'd recommend pausing this video and trying it. 8 times 6 is 48. 5 times 8, 40 plus 4. And then we need 2 numbers behind the decimal. So we're going to get 4.48. Now it says, what is the cost of this item with tax? So 4.48 is the tax. So we would need to do some decimal addition here. Add 56 plus $4.48, and you get $60.48. Now just to point out our method 2, where we do 100%, so this becomes 1.08. What would happen is you do the math here, and then you would add these 2 together and you'd still get the same answer. And that's it for today's lesson.